All right, here we are in Chapter 7, Section 2, problem number 9. A college athletic program wishes to estimate the average increase in total weight an athlete can lift in 3 different lifts after following a particular training program for 6 weeks. Okay, interesting there. I'm not sure if there's something there that gives us part of our statistics point yet, but there's some numbers there. Let's continue. 25 randomly selected athletes were placed on the program, exhibit a mean gain of 47.3 pounds, with standard deviation 6.4 pounds. Okay, so we've got a sample size of 25. So that's what our n equals. And the mean gain here is 47.3, and our standard deviation is going to be 6.4 pounds. So construct a 90% confidence interval for the mean increase in lifting capacity all athletes would experience if placed on the training program. Assume increases among all athletes are normally distributed. So since we're assuming this is normally distributed, we can start going further here and seeing what we've got. We've got our sample size is 25. I'm just going to write that as a 2.5 instead of having the wording out there, 25. And as I write that 25, that's less than 30, so we have to deal with a small sample size here versus large. So that's pointing us towards the t-distribution all right off the bat. And we don't have the actual population standard deviation, just the sample standard deviation, so we need to use the formula for our confidence interval of x bar plus or minus t at alpha over 2, standard deviation over the square root of our sample size. So our alpha level at this point is 10%, or 0.10. Alpha over 2 equals 0.05. So we're going to be needing t 0.05, and then we've got that degrees of freedom thing. So that's n minus 1, so we need to know t of 0.05 with degrees of freedom. 25 minus 1 as 24. Since we're going to need that, let's go ahead and look that up. So we're looking for the value of t with the alpha percent being 0.05 with degrees of freedom 24. So we're in the t 0.05 column down at row 24. That gets us a t value of 1.711. Okay, so I think we have what we need for our formula for our interval to get that confidence interval, our 90% confidence interval. We have our mean, 47.3 pounds, plus or minus our t at our alpha over 2, our alpha was 10, so alpha over 2 is 0.05, degrees of freedom 24, that's our 1.711, times our standard deviation, which was 6.4 pounds, divided by the square root of our sample size, so our sample size was 25, which is going to be 47.3 plus or minus 2.19. So we're going to be at 45.11 to 49.49 will be our confidence, our 90% confidence interval. So we're 90% confident that our population mean is between 45.11 and 49.49 pounds for our mean gain in this weightlifting program.